start by introducing Frank Visaggio. Frank is an engineering manager at General Atomics. Frank is a father, husband, hockey fan, active skier, novice road racer, and ever-struggling golfer. I hope you all enjoy his talk, What's New in JavaScript? Highlights from ECMAScript 2025. Give it up for Frank.
Thank you. So we're going to talk about the 2025 standard. This is the 16th edition of ECMAScript. I'll talk about why they call it that instead of JavaScript. Fun fact, Oracle still has the trademark, and they're clutching onto it really tightly. Maybe that'll change one day. But a little bit about me. I work on a platform team for General Atomics. We do a lot of geospatial software. That picture in the bottom left is sort of seeing like shipping lanes all over the world. So I don't know if you're ever going to go on a non-seaworthy vessel and it sinks, try to be in a shipping lane, maybe somebody will find you. But please don't, because the ocean's a pretty big place. Yeah, we're hiring. You can kind of see our hiring page. There's more offices than those locations. Those are just some that I thought of. It's kind of hard to keep track of these days. And a big thanks to three sets of people, yourselves for attending this talk, being here, interacting with the community, my wife and daughter for supporting me in everything, and then my coworkers just making life easier on a day-to-day basis and traveling from the East Coast and West Coast and Northern Utah to be here. So yeah, so let's talk about the 16th edition of the standard. So mentioned why, right? They don't call it JavaScript 2025 because they don't have the trademark. This group, they maintain the standards. They're sort of a consortium, and they have a couple other standards that they have. They have the JSON spec and also the C# language specification. I'm sure they have other ones. Those are the ones that kind of seemed relevant or worth mentioning. And you know, there's some benefits of having a standards organization. You don't have like one company dominating it, you know, making decisions that might be at odds with certain developers, so they can kind of think about like consistency across different browsers and making the web more predictable and reliable. And most importantly, like not breaking the web. I'll hopefully say that a couple of times. The biggest goal in these changes is don't break the web. Sometimes there's breaking changes, but there's very few considering there's been 16 different standards and 16 updates. So like it's really impressive on how well they are at not breaking the web. And they're trading off different things like the developer experience on how the API should work versus performance and other things, and all sorts of stakeholders, whether it's like the browser vendors, like the people making Firefox or SpiderMonkey or WebKit at Safari, and then developers trying to consume it in academia. So they're maintaining, you know, sort of that documentation and the standards that you'll see. So let's go for an example way back in 2023. So this is toSorted. So when toSorted was added, initially, right, if we look in the first sort here, initially sort would always mutate an array. So like if you had sort of an array and you call .sort on it, it would get mutated. And then they realized, you know what, like maybe that's not as ideal from a developer experience. We'll add toSorted, so instead you return a copy of that and it doesn't mutate. So like just, you know, question, who still prefers the sort where it mutates it in place? Like raise your hand if you prefer that, and then raise your hand if you prefer toSorted. So like, you know, a lot of people prefer toSorted. And you might be thinking, all right, well like, it's almost a no-brainer. Most people prefer it. Just change how sort works. Well, right? You'd think about that, but I'll give you a good example on why sort made sense when it was put in at the time, right? So like, if you think about it, we pass by reference for non-primitive data types, so like objects, arrays. So like that, you know, mutating it, just change how sorts work. Why do you even need a toSorted? But the reason that you can't just change that is there's so many sites like an old GeoCities, a site from 2006. You don't want to break the internet. You don't want to cause a whole bunch of breaking changes. So that's why they did that change. But now let's think about the history. Why on earth did sort work the way that it did? Why didn't they just get this right? And it's like, you know, no one has a crystal ball. But if we think back in time, sort, right, the original sort has been in Firefox 1, Chrome 1. So Firefox 1 was released in 2004. Now, I didn't want to, like, you know, make people think about inflation or anything, so I didn't add the prices of these computers, but In 2004, a budget PC had 64 megabits of RAM. Top gaming PCs had 128 megabytes of RAM. So mutating in place, not doing a better developer experience at the expense of memory, that was actually really strategic, given the hardware constraints at the time. So that's kind of why, I would argue they got it right then, and well, because you did that, unless you absolutely need a breaking change, don't do that breaking change. So that's kind of why they had to do two sorted. So to kind of see like the conflicts that they're trading off between developer experience and just not breaking the internet and everything that already depends on it, if you will. So TC39, they're the committee that maintains the standard. It's awesome. Everything they do, or everything that I know of they do, is on GitHub. So like all of their meetings, you can kind of go through, you can see the discussions, the trade-offs, et cetera. And like you'll have implementers from like Firefox, Google, all the different browsers, et cetera. And so far, since 2016, every year there's been a release. Now I'll say that, and maybe they skip a year and I look silly, but so far there's been a yearly release since 2016. And there's sort of a timeline that I'll discuss so you can see when things go in, but it's a very standardized process. Everything's on GitHub. You'll see the discussions, sort of like the trade-offs that they're doing when they decide to move things along the stages to eventually ship it into the spec. And once it's in the spec, most popular browsers will have it implemented ASAP, and I'll sort of give you an example of that. But if you're one of the people who is like, hey, why does something work this way? Temporal doesn't make sense. They should change it to this. You can comment on things, and people may listen to it, and they probably will, but you want to do it before stage 2.7. Once it's at stage 2.7, stage 3 and 4, it's locked down. That spec's not going to change. So look at things in like stage 1, where there's still the most active discussion, where the design still can change. So just to go through the stages, there's 4 stages, kind of 4 stages. I'll talk about this. 0 is not being considered. That's a straw person. Anyone can kind of propose that. And there's no entrance criteria. You just kind of need to have a document. You upload it on their GitLab page, and then you start with that, and you kind of make a case, like what improvement that one would want. Anybody can do it. Identify challenges. In order for it to go to the exploration stage or stage 1, it needs to be owned by the committee. So like you need to have a champion sort of identify and lead the proposal. You'll see like 4 or 5 champions on most of them. Some of them, right, temporal, which I'll maybe talk about at the end if I have enough time, that's been in stage 3 for 5 years. Sometimes, people lose interest, so the champions change, but sort of there's requirements for what the champions, what it takes to be a TC39 committee champion, and you need a champion to kind of carry it from stage 1 all the way till it ships till stage 4. But stage 1, you're kind of making a case for the solution. You'll see like existing libraries, like, hey, Rust does it this way, Java does it this way, maybe we should consider it, and like prior art, just to sort of inspire it and kind of flush out the API. Next would be the draft stage, stage 2. So like it's getting more concrete. You kind of know what the API looks like, the designs, probably standard. However, there's still a lot of unknown factors about implementing it. There might be some like really experimental implementations. Those polyfills, they'll give you a warning. They're not for prod. Heed those warnings, right? Like they are not as bulletproof as an actual implementation. It didn't pass the giant test suite that they have. So I wouldn't really use anything in stage, I honestly wouldn't use anything that isn't stage 4, that isn't ready. And then they have this weird, this wasn't always a stage 2.7. I hate it because it's kind of confusing. The way that I think of it is like stage 3 minus production-ready implementation. So like there's a whole bunch of like testing and validation that has to happen. You have to get feedback from all users on web browsers, maybe under experimental flags. That's kind of what 2.7 thinks. So like they're not really trying to make any changes to the spec that's not driven by like certain tests or performance feedback going in, but it's still waiting. And that's a stage that didn't always exist in regards to that. But like you have different reviewers kind of reviewing the feedback in order to promote it. And like one thing to worth mention is like, let's say there's something you really care about and it's in stage 2. They can sometimes go back. It's more rare that something goes back a stage, like stage 3, it's almost ready, and then it goes back to stage 2, but that is possible. So I say, like eventually I think temporal will be in. Who knows, maybe I'm really wrong and then it goes back a stage, but that's not impossible, if you will. It's unlikely, or it's less common, but it's there. And then stage 3, that's recommended for implementation. So like they know like, hey, it's definitely going to ship someday. It's just a matter of time and feedback. So you need the browser engines to implement it, and you need at least 2 major browser engines. Now, right, like you see that warning there in yellow. I took that from Temporal. It's like, it's experimental, right? Report bugs, but I'll give you a good example. Temporal is only implemented by Firefox. Safari has it under a feature flag, but there's like 6 to 8 P2 bugs. How critical are P2s? How bad are those bugs? I'm not sure. I don't know like exactly what they classify as a P2, but that's sort of like, hey, you can experiment with it. Do you want to ship it in a live application? Probably not, if you will. So, but it's really locked down. There's not going to be a lot of debate. They're not going to completely turn how it works on its head, if you will. So, they're just getting that time for the major browsers to implement it and have it ready to go there. And then stage 4, it's finished. It's ready to be included. It'll be in one version of the standard. So once something's in stage 4, you could start using it everywhere. And a big part of it getting to stage 4 is there's like a giant test suite. It's called Test 262, the acceptance test. All of those need to pass. They'll have a wealth of real-world usage, whether it's from feature flags and like it being implemented in at least 2 major browsers. Now, it needs to be in at least 2 major browsers. By the time it's stage 4, it'll be in most browsers, but that doesn't mean it's in every single browser. One example I'll show you, even though it's stage 4, I think Samsung Web didn't implement it yet. So like just because it's stage 4 doesn't mean like everywhere under the sun will support it. So keep that in mind. You can always go to like Can I Use or the Mozilla developer documents and sort of see the status of how mature and how along its implementation has been. So, and then here's one thing too. So like I'm going to start with I'm going to start with the start of the 2025 standard, but notice they have to call it. There's a timeline, right? So if we look at this, regex escape, right? They finalize, they make that call around February, and then the specs approved in June, July. So notice regex.escape, that made it to the 2025. Error.isError, that was approved, but it was approved in May. They already approved this spec, so that's going to go in next year for next year's standard. And you can, like, if you want, like, you can go see the spec on their page. You could request a print copy if you want this. I don't know if they still send out print copies, but like they need to kind of call the release at a certain point in time. So that's why it's, even though it makes it to stage 4, it might be in the next year, if you will. So just keep that in mind. Mind you, if it's in stage 4, probably the major browsers have support for it. And everything, like it's an incredibly transparent process. You could see from stage 0 to stage 4, all the issues, the meeting notes, what they talked about, concerns, changes, all of that's on their GitHub. So let's start with the first thing that was added. It was set methods, and that actually happened last year. It just happened after that cutoff. So they're like, hey, it can't fit in 2024. Let's add it to the next one. So let's just do a refresher, like sets, right? A whole bunch of a unique set of collections. So like if I have a set of like 1, 4, and 23, I can't add 23 again. So these new methods allow you to do different comparisons with sets. So like whether you want to see the difference of like what's in one set or not in the other, intersection, et cetera. I'm going to have some code examples on the next slide. And you can kind of see that. And this sort of graphic, if you're ever like trying to like visualize it and you can, MDN does a phenomenal job of visualizing, articulating this, like once they support things. So like this was taken from there. Big shout out to the documentation that they consistently deliver and how easy it is to understand different concepts. So let's take a look at a practical example of kind of how you can use these, if you will. Here's some of the new set methods. And a big takeaway why I think these are useful is like there's no need to manually like loop through the set or convert them to arrays to try to like do some of these comparisons. So if we look at line 2, right? Line 2, we'd say for this example would be my favorite foods and then my wife's favorite foods on line 5. So a little bit of a difference in there, et cetera. We have 2 different unique sets. Mind you, if I added pizza again to either one of us, it wouldn't add that again. everything needs to be unique, so it wouldn't be there. So if we look at line 8, we would sort of see the union, right? What's sort of all of the unique foods, like you combine everything from my set and her set, that's the combined collection. So that's like both of the circles shaded on the outsides and the inside. If we look at line 12, right, this would be the new intersection. So like what's the overlap? You have my set, the other set, what's the part in the middle? So in this case, it would be sort of pizza and sushi. The difference, right? You want to compare one set to another. So with the difference, kind of like, maybe foods that I like that she doesn't. So if I take my set and that, well, she doesn't have an overlap of Chipotle and Mongolian in there. And then sort of like that symmetric difference. So things that are uniquely in each different set but not shared. So like maybe a good thing to change, that's sort of what the symmetric difference would look like on line 23. And then you can also kind of see like subsets. So like does one set fit inside of another set? So like is everything like, will I just eat anything that she likes to eat? So does my set fit entirely inside of her set? And that would be false here because not all of my elements are in the sets of line 5. And then the opposite too, is it a superset? So if you think about it the other way between the sets in line 2 and line 5, that would also be false in this scenario. And then lastly, the last one is like, is disjoint? So like, are they completely separate? Is there absolutely no overlap? It will return a Boolean. And in this case, there is some overlap. It would be the pizza and sushi elements. So that would return false. The next one that I want to share, so like like if you're not a football fan, I have 2 football examples. Comment, like this will be on YouTube, comment better ideas of examples. I always struggle on like what's relatable. But yeah, that's what I kind of thought of. And there's a positive if you do care about this of like, I could spin it either way, which maybe I will, but we can import JSON modules directly into JavaScript. So like you kind of just put that type JSON there. And that ensures the modules treat it as JSON and not executable code. And it's pretty cool. Like you can kind of do that without the need for any bundlers. And I think this would be pretty useful for like feature flags or different config imports or maybe even different like language packs that you might need to add in certain pages, especially like isolated web components where like maybe you don't need that language pack everywhere. So that's kind of how I think of it. There's another follow-on to this where like it's not ready yet, but you can also change that type to where you can import CSS. I think it only works in Chrome for now. I don't think anybody else other than Chrome can do it. But it's pretty cool to do that without a bundler, and you can also import HTML partials. So if we kind of look at this example, let's assume I have like player.json, and it's Micah Parsons, who happens to be on Green Bay now. And you import that, then you can access the different properties there of like sort of, his name, team, et cetera. And like the pick-me-up is like, sure, Green Bay's winning with him, but if you think about it, Dallas got 4 first-round picks. If you're old enough, the last time they traded for Herschel Walker and 3 picks, they won 3 Super Bowls in 4 years. So like, any way you look at that current event, it could be positive if you care about one of those teams. And if you don't, who cares? Football will be over in 16, 17 weeks. So that's a good way to, have a pick-me-up, no matter how much you care about that topic. The next thing is regex escape. And my apologies, that image is a little bit small at the top right, but that's from, I think it's from Can I Use? And notice this is stage 4. It's shipped, it's in the standard, but Samsung Internet doesn't support it yet, right? Like, and maybe there's performance issues. Maybe they think it'll crash their browser. I don't know why, I didn't look why, but just because it's in the standard doesn't mean every single browser implementer can be there. And sometimes they have good reasons for like performance trade-offs or developer experience. So like, don't just assume it's in the standard, it should work everywhere. I'm sure there's a polyfill for it, but that's just a heads up. So what's pretty neat is like, if you think about it, right? Let's say you have some user input. Sometimes you'll have like special characters and you think, why would anybody ever do that? And it's, your QA just throwing in stars in there or $signs, et cetera. But a lot of times that'll mess up regexes because those are treated specially with regex. So like if I'm looking on line 6 and I want to look for the search term, I want to see a price of $5, right? And then I look for the regex and G will get global or all of the matches of that. Well, it's not going to hit on that, right? In line 10, it's going to be undefined, and the reason is because in regular expressions, $ means end of line, right? And then the dot means any character. So really, that price, $5, is interpreted as price, colon, and then it's going to look for an end of the line character, right? And then it's going to look for that any character in the dots. So that's why it's not going to hit. So you're thinking like, okay, how do I escape this? Would I spread it out and like change that? Well, now it's really easy in my opinion. And maybe you're just, maybe this is not as common of a use case where like you could kind of code your way around it. But like if we look in line 21, that regex.escape, you kind of just do the regex.escape, and then you can throw it in there with the special characters, and it'll match just fine. You don't have to think about like, what is $ again in regex? What is the any character, end of line, et cetera. So that kind of makes it a little bit easier, especially if you're not necessarily a regular expression master like myself. Iterator helpers. So this is pretty neat. There's a whole bunch of methods for iterators. So let's just do a quick little recap on like some of the reasons iterators can be helpful. And so like if we think about it, an iterator is a way to represent a pretty large or almost an infinite data set. So there's a lot of performance benefits. You have reduced memory pressure because you can yield one value at a time rather than like allocating all objects at once. So if you're streaming like, I don't know, a gigantic novel or something, you don't need to buffer that entire data set. You can just process the chunks as they arrive, or like a live event or something. So for a while, we've lacked helper methods to sort of easily manipulate iterators. And the crutch that people would do is they would just, convert it to an array, and then you kind of lose some of the benefits of manipulating that. And notice there is the to array to just make that even easier too, if you want to do that. So let me just show you, let's start with an overview of iterators, and then I'll kind of show you how the new methods work, if you will. So if you have a function with a star after it, that's a generator, and that'll yield different values, right? And then you call next to yield the next value. So here we have, a couple sports quotes. I wasn't very creative in thinking of the example here. So, and that'll just go through every time we yield on that, it'll do the quote on line 6, then 7, then 8, and keep going back and forth, if you will. So with that, you can kind of, in line like 20 and 21, when you call next to kind of get the next yielded value, you'll get the first one, winning isn't everything, and so on and so forth. So that's an overview of like the iterators. So now let's kind of see what we can do with the new methods, if you will. So drop. So this one takes an integer, and it'll just drop the first n number of elements produced by the iterator before producing any remaining events. So here, we're just going to yield 1 to 3. So if I drop the first 2 in line 7, when I call next to iterate the next value, it'll just start at 3. Now, if I call next again, it's not going to iterate through it again. Once you go through it once, it's done. It'll say, okay, it's now undefined. That iterator is done. So you'd have to get another iterator if you wanted to go back through it. And that's going to be important with like some of the comparisons. It'll short circuit, which can be pretty significant in regards to performance from my perspective. This next one, the every function. So that'll take a function and pretty much return a Boolean, and seeing if every value in the iterator kind of satisfies what you pass in there. And so yeah, like I mentioned, it'll short circuit as soon as it finds a value that fails the condition. So if I have like test scores, right? The first set of test scores in the function in line 1 in that iterator. So if I want to make sure everything is greater than 70, greater than or equal to 70, they'll all pass, right? So I can call that .every. And then if I change that up and I add a test score of 50 in there in line 9, and I pass that again, it'll fail. So, and it'll short circuit. It's not going to yield the 88, the 90. If there was a million values in there, it's not going to keep going through. The second it hits that 50, it's done, right? So if it's like, hey, if somebody fails this test, I don't know, everybody's I don't know, coming to class on Saturday. The second it goes there, I guess everybody's showing up on Saturday. So filter, this is the next one that I can kind of think of. Filter, you'll sort of filter values from an iterator that doesn't pass a function. So if you're not from Utah, a lot of awesome skiing here, a lot of awesome skiing outside of Utah as well. I'm a transplant, so part of the ski traffic problem. But if we have a bunch of our favorite resorts here, and we kind of we want to filter on the highest elevation. So let's say the elevation's over 9,000. We could pass that into the filter, and then what you'll get back. And notice I say for performance reasons, don't be so quick to go from an iterator to an array. And I did that in this example. So I guess do as I say, not as I show, or something like that. But it wouldn't return Brighton because Brighton's elevation is less than 9,000 feet. But Brighton still has awesome night skiing, awesome place. So don't use this example to affect where you're going to ski this winter. And if you didn't plan on skiing, I don't know, maybe consider it. It's pretty delightful here. Take, right? Taking the first element. So this one's pretty simple. You can kind of have a ticket line. So let's say we're dealing with supply constraints of a Taylor Swift concert, and you're like, okay, right now we're just going to release 2 in the first batch. If I take 2 in line 11, right, when I yield those values, you'd sort of get Frank first, and then Ashley and Denver, and then that's it, right? And then it would be undefined, and that iterator would be done there, if you will. And I think where it's really powerful is you can chain these together. So unfortunately, right, another fantasy football example, but if you have a whole bunch of people there in lines 3 to 7, we can sort of chain these together. So if I could just want to NFL players, so my first example, right, we'll filter, so just take only the wide receivers, so that means Travis Kelce gets dropped, and then we're going to map it, so all I care about is the name and the projected points, and then take the first 3. That's kind of what you would get. So Travis Hunter's left off. And then here's another one, right? A similar example of that chaining. So if I want everybody who's projected to be over 15 points, so I'm going to filter, I'm going to drop anyone who doesn't have position of WR, wide receiver. So that means line 6 gets dropped, Travis Kelce. Sorry, Travis. And then we'll sort of map that, so we just have the name and the projected points, take the first 3, and then I want to make sure, and then it's okay, every one of those, so every one of those wide receivers, Justin Jefferson, Tyreek Hill, and Jamar Chase, are they projected to be over 15 points this week? And they are, so that would return true. So that's kind of how you can chain those together to do more complex logic from iterators. This next one is pretty neat as well. So Promise.try. So what's unique about this is you have immediate execution, like calling a function normally. So it's really good when you have APIs where you don't know if the function's going to return a promise or not. You don't know if it's synchronous. It's maybe you're less likely to use it if you control all of the code, but I'll kind of talk through on how you could use it. So in this example, you can kind of use the catch to handle with Promise.try. That catch and that finally, you can use that to handle both asynchronous and synchronous exceptions. And the problem would be before this try is the synchronous problem would be that error would throw before the promise.resolve happens. So you'd kind of lose it if you thought you were going to get a promise and you didn't, and it actually ran in synchronous. So it's kind of the example that I can think of. If we just look at this example, you sort of have the action, that callback function that's coming in, and no matter what you really throw at it, it'll kind of just work, right? So it's the bulk of the API is promise.try in line 3, and then it'll do the then, log that result, it'll catch the error, and then it'll do the finally. And without the try, right, I couldn't do the then or the catch or the finally if I didn't know that it was a promise. Now, there was ways around this. It kind of just makes it a little bit cleaner to do this. So The different types of functions that this will handle fine is like you have a synchronous function, function 1, and line 10, right? And that just returns a string. You'll kind of see that result. The promise will be fulfilled, and you'll be on your way, right? If you have a synchronous function that throws an error, the error will be thrown. You'll see that done, and then the promise will be fulfilled. And then you can see a little spelling typo. Yeah, so now async, right? Asynchronous functions always return a promise. So then you can also throw in those asynchronous functions to that callback, and you'll sort of either get the result, it'll be fulfilled, or if it threw an error, it'll handle that error just as well. So kind of adds a little bit more flexibility while writing a little bit less code with that try. This next one, if you're like, okay, where's the hype, right? And I don't know if hype is not a constraint of the TC39 committee, but maybe there's a little here. Maybe I'm exaggerating, but we have float 16, and you're like, all right, a 16-bit float instead of a 32-bit float, right? Where's the AI machine learning impacts? And it's like, everybody has an AI ML impact. I just looked at Oracle's stock price going up like crazy on Thursday, and they still won't give up the JavaScript trademark. But here's our hype for this year. So, who cares, right? It's half the size of a float 32. Well, here's why you might care. Right, making floats that are half the size, that could be pretty useful for GPU operations where precision isn't as necessary and memory constraints add up. So I think of if you're going to do large graphical things like a really large map or an area, and maybe you need less detail, that could be useful for such a scenario. Matrix multiplication for large machine learning libraries. Here's maybe a more practical one, stable diffusion, where you have you can type in a text prompt and you'll get an image from that. Those require crazy amounts of memory, even on really good GPUs. So rather than using 4 bytes per value, you only have 2 bytes per value, so you can hold a lot more in memory. And why should you care? I mean, just simple libraries on Hugging Face, that can be the difference between it working or it crashing. For libraries that may not be that crazy in regards to what it's doing, but and even if you're hey, I have a decent GPU, right, a 3070 or something, and maybe my definition of a decent GPU is not what yours is, but it really can help out there. So the real world example is you get more data with a little bit less precision. So if I think about that, right, so what would that look like if I'm trying to figure out, is there a car in this picture? I could train it with more samples of more different images of cars. Maybe I can add the batch of cars in a car wash as training data. Otherwise, I'd have to leave that out, but you're going to have less precision. So if you know the difference between a Corvette and a Camaro, maybe it wouldn't pick up on that. It wouldn't realize that the Camaro has back seats, and it wouldn't be able to do that. So it's in those scenarios where having too little data is the bigger problem than small rounding issues. Mind you, full disclosure, I'm not a machine learning expert, so I don't know if this causes some bugs, and I just use your own caution when considering this, but let's look at the code example. So, let's say we have an array buffer with 4 bytes of data, so you can now fit 2 16-bit floats in there. The API changes are on lines 8 and 9, so you can sort of set float at the first offset, right, throw in pi, at the second offset, throw in negative 2.75, and then get that back in lines 12 and 13 in regards to accessing those new 16-bit floats, if you will. So that's how it's used. Thanks for attending this. I have one more slide because I have about 5 more minutes, so I'll do the one slide. It's stage 3. That's everything that was stage 4. My daughter and I running into this weekend, but let's do the bonus slide. So the bonus slide is temporal, right? And let me if you've seen a talk in the past, I've talked about this, and it's I think it's coming, I think it's coming. Honestly, I don't know when it's coming. This has been in stage 3 since 2020, but it's pretty cool in my opinion. There could be reasons why it's delayed, like the performance compared to some of the other alternatives. It's not necessarily faster. So is that the reason why it's held up? I'm not sure. Here's the main reason. Only Firefox has it regularly available. You need a second major browser, so it being behind a feature flag in Safari, that's not good enough. but it's pretty streamlined in how it works. So like if you have a plain date, you could sort of, add 5 days in line 2. If you sort of, want just a plain time, I don't care about dates, I don't care about time zones, you can work with plain times. You can get a plain date time in line 6. You can work with durations, right? So like P is a time period. So if I want to add 2 hours and 30 minutes to that time that I have, you could sort of just add that duration, and that's sort of the output on line 10. You can compare different dates and sort of get that. So if I compare the two, I'll see -1 that it's earlier. A lot of like different problems that you want to solve with like time and dates, I think Temporal handles it well once it ships. So I'm kind of looking forward to this. You can convert between different time zones, if you will. So like if I have an ISO time and then I want to say, okay, like change that to New York City time zone, you can do that seamlessly. No, it's all built into Temporal, which I think is pretty nice. See the difference? So like in lines 22 and 23, that's a leap year. If you're familiar with the ISO time standards, P equals period, so like period 366 days because it's a leap year. Doing that comparison, so I think this is going to be pretty neat when it ships. When's it going to ship? I don't know. It's been 5 years, maybe soon. Maybe they'll approve it right after this. So that's kind of everything that I have. Thanks a ton for attending, being here, and try to get to know other people in your community.